So number one, we have a quadratic here, and it's just like any other equation. When you want to get rid of something, you do the opposite, and the opposite of a square is a square root. So when you apply a square root, what you do to one side, you have to do to the other. When you apply a square root on an equation, you have to put the plus or minus sign right in front of your answer. So now you have x by itself equals, the square root of 9 is 3, but of course we have to put a plus or minus 3. What that really means is that x equals 3 and x equals negative 3. But who wants to write all of this when you could just write it with the plus minus right in front? So don't write all of this, right? Just keep it as x equals plus or minus 3. Yay? Okay, moving on. Number two. One option is to write this binomial twice, x plus 3 times x plus 3, and do a bunch of distributive property and combining like terms. But that's a horrible mess. It takes a long time. How about we focus in on getting rid of the square? Let's get x by itself. Yeah, I want to get rid of the 3, but I also want to get rid of this little 2 up here, which is a square. How do I get rid of something? Doing the opposite. And what is the opposite of square? Square root. So we're going to square root and square root. And of course, remember, when you square root, you have to put a plus or minus in front of your answer. So the square root and the square, they end up eliminating themselves, and all you have left is the x plus 3. No more square. You don't even need the parentheses anymore. But on the right side, you now have a plus or minus 5. Now, what does that mean? It could be positive 5, and it could also be negative 5. So we still haven't finished. We still need to get rid of the plus 3. We're going to subtract 3. So subtract 3 to the other side. Now notice that I didn't put this minus 3 right underneath the 5. If I could actually combine them, I would put it right underneath, but I put it over here in front. Because you can't really combine negative 3 with the plus minus 5. That's really two different numbers. So what I'm going to do is rewrite it. X equals negative 3 plus or minus 5. And now let me actually write what plus or minus 5 actually looks like with that negative 3 in front. That's really going to be a negative 3 plus 5, and it's also going to be a negative 3 minus 5. So you actually get two answers. The negative 3 plus 5 is what? 2. And the other one? Negative 8. All right, so those are your two answers. All right. Just for kicks, let's review what answers really mean. Back before Thanksgiving break, we said that the answers were the solutions, which were also known as the roots. They were also known as the x-intercepts, right? So if this original one were a quadratic equation, y equals x squared minus 9 or something like that, then it would actually cross at 3 and negative 3. The x-intercept values would be at 3 and negative 3. Over here, if this were to be a function as like a quadratic, y equals x squared, or y equals this x squared minus 25, then it would cross, that parabola would cross at 2 and negative 8. We don't need to worry about that right now, but later on we will. Answers are x-intercepts. Just remember that. Number 3, what do I do? Same answer? Different question, right? Yeah, different question. All right, so let's square root and square root. And you get x minus 5 equals plus or minus 3. And that's not a minus 5, that's a plus 5. So we have x plus 5 equals plus or minus 3. So now let's solve this thing by subtracting 5 and subtracting 5. You're going to have x equals negative 5 plus or minus 3. Okay? So the negative 5 plus or minus 3, that gives you actually two answers. It gives you the negative 5 plus 3, and it also gives you the negative 5 minus 3. So the top answer is going to be negative 2. The bottom answer is going to be negative 8. Agreed? So they weren't exactly the same answers. Kind of. Moving on to, do we understand 1, 2, and 3 though? Yeah? Okay, you guys copied down 4? Did you get a chance to do number 4 and 5? Or not yet? Let me pause it. So, ladies and gentlemen, if you're taking a look at number 4, you should recognize that this is a perfect square. This is what we call a perfect square quadratic trinomial. All right, perfect square quadratic trinomial. Now, what does that mean? That means that if you were to factor it, I mean, let's think about this the way we normally think about it when we factor. Ignoring the 25, let's just focus in on x squared plus 6x plus 9. How do we factor that? We normally put parenthesis, 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 x, x, and we think what times what is 9, that if you add together is 6. 3 and 3, right? And that would be positive 3 and positive 3. Now the reason why we call this a perfect square quadratic trinomial is because you're able to write these guys as x plus 3 squared. Are you guys following me? That's why it's called the perfect square quadratic trinomial, right? So you're actually able to write it as a binomial squared. I hope everybody understands that. We have the equals 25 that comes down, and now we have the same type of situation that we had on questions 1, 2, and 3 on this opener, right? So how would you get rid of the square root? Now, I'm running out of space, so I'm going to zoom in here. So we're going to get rid of the square by square rooting. What you do to one side, do to the other. You're going to have x plus 3 equals plus or minus 5. You need to put the plus or minus in front of your answer whenever you take the square root in an equation. And then we're going to subtract 3 and subtract 3. So you're going to rewrite this thing. It's going to say x equals negative 3 plus or minus 5. And now that's going to give us two answers. That's going to give us negative 3 plus 5, and it's also going to give us negative 3 minus 5. Now the negative 3 plus 5 is really the answer 2, and the negative 3 minus 5 is the answer negative 8. Okie doke. All right, let's try the next one. So this is also a perfect square quadratic trinomial, because you're going to be able to end up writing this as a binomial squared. Now maybe I'm getting a little ahead of myself. Let's think about this. What times what is 25 that if I add together is 10? 5 and 5, right? So we should know that you end up with x plus 5 times x plus 5, which ends up giving us the x plus 5 squared situation. Do you guys all see that shortcut right there? I skipped a step. Maybe I shouldn't. Let me do it then. Here's a binomial, x, x, and you think, okay, what times what is 25 that if I add together is 10? Oh, that's a plus 5 and a plus 5. And then you go from this exact x plus 5 times x plus 5, and we rewrite it as x plus 5 squared. And we're going to now bring down the 9, and we're going to now square root and square root. And we will have x plus 5 equals plus or minus 3. So I'm going to get rid of that plus 5 by going minus 5, minus 5. And you're going to end up with x equals negative 5 plus or minus 3. And that gives you two answers. Gives you negative 5 plus 3. I might as well get the answer to that. That's negative 2. And it also gives you negative 5 minus 3, which also gives you a negative 8. That's an ugly 8. Huh? Likely. Could have been. Yeah. Yeah. So I hope we understand that sometimes we're able to, or maybe I shouldn't say we understand, but I hope we recognize that when we have a perfect square quadratic trinomial, that means you're able to write it as a binomial squared, and then you do the square root on both sides and solve that way. Okay? So what we're going to learn on today's lesson is how to create those perfect square quadratic trinomials. Okay, so let's just go through this exercise, see if we could figure this out together here. It says find the c-value that would make the following a perfect square trinomial. Okay, what number do you think would fit right here? Let me zoom in on 6. What number do you think would fit right here that would give me the same exact binomial, so I could write it as a binomial squared? 5? 25. 5 or 25? 25. Excellent. Now the question is, let's not even ask how we got that. But yeah, 25 is right. Okay. How about number 7 over here? And once again, what value right here would make this give you the same exact binomial here and here that ultimately you'll be able to write as a binomial squared? Now, why do we want to write it as a binomial squared? Because on an equation, if you have a binomial squared, you could square root to get rid of it, right? Okay, so what value would give it? 9. Everybody sure about that? Yeah. 9. Excellent. So this is a 9 right here. How about here? 16. 16, good. Wait, how about number 9? 36. How the heck are you guys getting these perfect c values? How is it? Okay, so here's the deal, guys. We need to come. You guys are getting all these right, and that's that's the hardest part of today's lesson, to come up with these numbers that you guys are coming up with. But we need to be able to write down verbally the steps on how to get this 36. How did we get this 36? 6 plus 6, 6 times 6, what? Right? Okay, but we didn't even know this 36 to start with. So it was blank. We didn't have the 36. So, okay, there you go. So you're thinking the 12, what do I need to do to this 12 to be able to get the 36? Now here's the bottom line. Step 1 is to take half of 12. And then what do you do with that half of 12? You square it. Okay? So step 1 is to take half of b and then square it. Step 2, square it. Right? So what we're doing on all of these, now you guys were doing that without even knowing those steps. Right? But like half of 6, what's half of 6? 3. What's 3 squared? 9. You guys did that in your head without explaining it, right? 12, what's half of 12? What's 6 squared? 36, right? Let's go back up here. What's half of 10? What's 5 squared? 25. So what we need to learn, half of 8? Half of 8? 4 squared? 16. Okay, so what we need to learn is this. What you need to learn is to get that perfect c value, you must take half of b and then square it. That's the verbal description up here. Here's the algebraic, right, with the algebra. b over 2 and then square it, okay? So let's go back and continue right here. How about number 10? 81, right? Because you took half of 18, that's 9, and 9 squared is 81. How about number 11 over here? That would be 4, because half of 4 is 2 and 2 squared is 4. Now some people really mess up on number 12. Yeah, half of 1 is what? 0.5 or 1/2. And now you need to square it. So what is 1/2 squared? What's 1/2 times 1/2? 1/4. So your perfect c value right there would be 1/4 or 0.25 if you want to write it as a decimal. Anyway, what we're actually doing on question 6 through 12 is a method called completing the square. And this is what you actually need to know. This is what's really important for today. To get that perfect c value that you're looking for, you must take half of b, then square it. b over 2, square it, right? We're going to pick up on this on the next video.